Hello and welcome to the Unit 8 review for our unit on trigonometry. Hopefully you'll find that when we finish these 10 problems, you'll be ready for tomorrow's test. Let's start with number 1. So we're going to be comparing cosine 0 and sine of pi over 2. We're going to determine which is less than, which is greater than, or if they're equal to each other. So to start off, let's find cosine of 0. So first I need to find, first of all, this is what I'm always going to do in my very first step. Okay, step 1, we're going to write the formula. And when I say write the formula, I mean x, y, and r. So first step, cosine, when we refer to cosine, we're dealing with x over r. And when we're dealing with sine, we're dealing with y over r. So let's just start there. Okay, second step, we're going to draw the angle. So cosine of 0 means that I need to be at 0 degrees. Well, 0 degrees is over here to the right. So I'm going to draw a point since it's on our axis. Okay, notice right now that that 0 degrees and pi over 2 are both axis angles. I'm going to highlight them. That means they lie on one of these 4 axes when we do an xy axis. So we have a special set of rules for these axis angles. We set our radius equal to 1 as always. And then we have to think about this as a point, an xy point. If I'm moving from my origin over 1 unit to the right, that means that my x is going to be a positive 1, and that y, since I'm not going up or down on the y-axis, my y value is going to be 0. Similarly, up here at 90 degrees, so this is 0 degrees or 360 degrees. Up here at 90 degrees or at pi over 2, that point would be 0, 1. See if you can figure out why. On my x-axis, I'm not going to move to the left or to the right. I just want to stay where I'm at. And I only want to move 1 unit in the positive direction, up. So that's why y is positive 1. So that's how we deal with our axis angles. So now that we have drawn our angle, our final step is to just plug in. So at 0 degrees, so I'm back here now. At 0 degrees, that's over here, my x is 1, and my r is 1. 1 over 1 leaves me with 1, so I know cosine of 0 is equal to 1. Now let's do sine of pi over 2. So we have to draw pi over 2. Now I'm going to use green. That's pi over 2. It's on our axis, so we label it. We give it our point, 0, 1. And sine is y over r, so my y value in this case is 1. And my r is also 1. That's this distance. So 1 over 1 equals 1. So cosine 0 and sine of pi over 2 are equal to each other. Let's move on to the next problem. Sine of pi versus secant of negative pi. So anytime I see like secant or later I'm going to see cosecant, the first thing that I like to do is to write down my formulas. Sine theta is y over r. Cosine theta is x over r. And tan theta is y over x. I do that because I don't have these guys memorized, but I do know that secant is the reciprocal of cosine. So different people have different tricks for remembering which are reciprocals. For me, I just remember if this guy starts with an S, then its partner starts with a C. And then down here, cosecant starts with a C, so its reciprocal starts with an S. That's just how I do it. You may have learned a different way in your class, and that's fine, as long as you remember them. So let's write our formulas first. Sine is y over r. And then secant. Well, secant's the reciprocal of cosine. So instead of x over r, it's going to be r over x. Cool. Next step. Let's plot these angles. So we need to figure out where pi is. Well, pi is the same as 180 degrees. And 180 degrees puts me over here. My r is equal to 1, And now our point is negative 1, 0. That's my x, that's my y. So y over r is going to be 0, because that's my y value, over r, which is 1. Sine of pi is 0. Next, I need secant of negative pi. So this is the first time we have negative degrees. This is the only difference between negative degrees and positive degrees. Okay, if I were to ask you to find 30 degrees, you should know it's somewhere around here, right? And that would be like 30 degrees. From 0, we go 30. If I said plot negative 30 degrees, instead of just measuring 30 degrees counterclockwise like this, you would go backwards. So 30 degrees would actually end up over here. Negative 30 degrees would end up in the blue arrow region. So what I like to tell my students is, hey, if you're asked to plot something like, say, negative 120 degrees, first go to where you know the positive version is. I know 120 degrees is like over here, and it's 60 degrees less than 180. So once you've plotted the positive version, just flip that over the x-axis like this. This is where negative 100 degrees is. See how we went backwards the same amount? And it'll have the same reference angle. So you can see that the same rule kind of applied over here with our 30 and our negative 30. It's just flipped up and down. So if I want to graph negative pi, I can do it one of two ways. I can either think about where 100 degrees takes me and then go the opposite direction, the same amount, and it'll take me right there. Or I can plot my regular 180 degrees and then flip it across the x-axis. Well, in this case, I'm on the x-axis, so I'm going to stay right where I'm at. So as I'm showing you, negative 180 degrees and positive 180 degrees both take me to the same spot. That's on the left axis. So we have the same xy points, negative 1, 0. Secant is r over x. Well, r is going to be 1, and x is negative 1. So my answer is negative 1 here. So which is greater? Well, 0 is greater than negative 1. I'm comparing my sine and my secant. Okay, next problem. We're going to do tangent of 9 pi over 2 and secant of pi over 2. So I'm just going to draw a fresh axis so it looks nice and clean. So let's see where tangent of 9 pi over 2 is. Okay, so pi over 2 is right over here. And I know that 3 pi over 2 is down here. So here's what you should remember. If pi over 2 is 90 degrees, then each pi over 2 is going to take me an additional quadrant to the next axis. So this would be 1 pi over 2. This would take me to 2 pi over 2, which is just pi, 3 pi over 2, 4 pi over 2, and now on my second round, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, last round, and then 9 pi over 2 will leave me right up here. If you're like, whoa, that was insane, I'm never going to be able to do that, you can also try it like this. Do your conversion, 9 pi over 2 times 180 over pi, and then simplify. The pi's will cancel. The 180 will turn into a 90, and the 2 will turn into a 1. They'll cancel. And I'm left with 810 degrees. So 810 degrees is a lot more than one circle, right? That's 360. And if I go another 360, that takes me to 720. So the question to ask is, after I've made 2 full circles, how much further do we need to go to reach 810? So I'll do the math like this. I'll do 810 minus 1 full circle. And then I'm going to minus another full circle. And I see that I'm actually going to be at the same spot as 90 degrees, which is what we discovered by this kind of rotating method. So let's draw at 90 degrees. That's where 9 pi over 2 really is. And that's r equals 1. My point is 0, 1. That's x and y. And tangent, my tangent formula is y over x. So y is 1 and x is 0. Anytime you divide by 0, the answer is does not exist or undefined. That's interesting. Let's see what we get when we do cosecant of pi over 2. So cosecant, since it starts with a co, is going to be the reciprocal of sine theta. So instead of y over r, we're dealing with r over y. So my r here is 1, and my y is 1. So cosecant of pi over 2 is 1. So which one is greater? Well, I think that's kind of a strange question. I'm going to put a question mark because I can't really compare 1 with does not exist. So I'll be okay with like an ambiguous answer there, as long as you know that tangent of our 9 pi over 2 is going to be does not exist because we're dividing by 0. Okay, let's move on to number 2. Number 2 says find cotangent of negative 5 pi over 4. So let's figure this out. Negative 5 pi over 4. So to figure out where I'm going to plot that, I'm going to first plot normal 5 pi over 4, which will take me, 5 pi over 4 is over here. It's equal to 225 degrees. Negative 225 degrees. But I need to go in the opposite direction because this is a negative angle. So instead, I'm going to end up somewhere over here. So don't stress too hard about where exactly you end up. Just flip it over the x-axis. Flip it up and down. So we're actually going to be plotting this guy. It's going to have a reference angle of 45 degrees. And I know that because this is a multiple of 45. And then I'm going to drop the perpendicular. Cotangent, by the way, is the reciprocal of tangent. So instead of y over x, it'll be x over y. And if you remember your big 3, across the 45 degrees, we always get root 2 over 2. And that's going to be positive. Our x is going to be negative root 2 over 2, because I'm going to the left. And then r is always equal to 1. So cotangent of negative 5 pi over 4 is going to give me my x is negative root 2 over 2. My y is positive root 2 over 2. And you'll notice that these guys can cancel because they're the same on the top and bottom. And we'll be left with a negative 1. All right, let's go to number 3 now. So we've got these same rules as before. It says use special right triangles to find the trig functions. So step 1, we're going to write our formula. Tangent is y over x. Next, we're going to draw our angle. We need to draw 150 degrees. So 150 degrees, let's see where that will take me. If this is 0, this is 90, and this is 180, 150 degrees will be before 180. And now I need to actually find my reference angle. That's this distance here. So if this is 150, and this whole thing is 180, then if I subtract the two, I will get the leftover, which is this amount right here. So I'm going to do the subtraction, 180 minus 150, and I realize, okay, my reference angle is 30 degrees, so label it right away. Next, we're going to drop our perpendicular to the x-axis. If that's 30, that means this must be 60. And now we can label based on our big 3. So see if this comes back. Across 30 degrees is always 1/2. Across 60 degrees is root 3 over 2. And then across our 45 is always root 2 over 2. And r is always equal to 1. It's always equal to positive 1. So let's label. Across 30, 1 over 2. Across 60, root 3 over 2. And I have to make sure that I mark that as negative because I'm moving to the left. And then our radius or our hypotenuse is 1. That's x. Whoops, that's actually y. That's x. And that's r. So if tangent is y over x, I'm going to show the work down here. My y is 1/2. My x is negative root 3 over 2. And if you're familiar with the rules of complex fractions, if I have the same denominator, they'll cancel. I'll be left with 1 over negative radical 3. And then in our final step, we can't really leave a square root in the denominator, so we're going to multiply the top and bottom by root 3 to get rid of it. And we'll be left with root 3 over 3 with that negative in front. Now I could have done this a slightly different way, so let me show you that. If I have y over x equals 1/2 over negative root 3 over 2, you could do drop, switch, flip, and do 1/2 times the reciprocal of the denominator. So that would be negative 2 over root 3. And you'll get the same thing as we did last time. The 2's are going to cancel. Negative 1 over root 3. And then finally rationalize for the same answer. So whether you cancel the denominators right away or show the multiplication by the reciprocal, you're going to end up with the same answer, which is negative square root 3 over 3. Next, let's work with cosecant. So cosecant is the reciprocal of sine theta. And if sine is y over r, then cosecant is going to be r over y. Notice that we're dealing with the same angle, so I don't need to redraw anything because I've already drawn 150. I've already labeled my reference angle as 30, and I've already labeled my y, x, and r sides. So I just need my r, which is 1, over my y, which is 1/2. Okay, I'm going to show the work down here one more time because we got a little bit of work to do. If r is 1 and then y is 1/2, I'm going to do the same drop, switch, flip. I'll set this as a fraction, 1 over 1. So this is the same as 1 over 1 times the reciprocal of the denominator, which is 2 over 1. And I'll see my answer is just 2. Positive 2. Okay, in our last problem, we have sine of 150. I need y over r. So my y is 1/2 over r, which is 1. But like anytime you're dividing by 1, you can really just ignore that. That's the same as 1/2. Okay. Let's move on to number 4. True or false? Is cosecant of 210 equal to secant of 240? Well, there's only one way to answer this, and that is to find the values of each. So we're going to have to do kind of like two problems here. First, we'll find out cosecant of 210. So, step one, let's write our formula. Cosecant is the reciprocal of sine theta. And if sine is y over r, then cosecant is going to be r over y. So we wrote our formula. Now let's draw our angle. Okay, 210 is going to be past 180. And just how much past 180 is what I need to figure out, because I need to find out what this reference angle is. So if this is 210 degrees and that's 180, then if I simply subtract the big angle minus the small angle, I'll be left with their difference, which is this piece right here. So let's do the subtraction. 210 minus 180 leaves me with 30 degrees. That's my reference angle, and I'll label it. Drop the perpendicular, and now we're going to label our sides. Across the 30 degrees, we always get 1/2. But since I'm going down in the y-axis, this is going to be negative 1/2. Next, we have to label our 60 degrees right here. Now, across from my 60 is going to be negative root 3 over 2, and my r is always equal to 1. So that would be x, this would be y. Now, cosecant is r over y, so that's going to be 1 over y, which is negative 1/2. We've got a complex fraction, so we need to do some work. So let's do the numerator, which is 1 over 1, times the reciprocal of the denominator, which is negative 2 over 1, and our answer is negative 2. Let's compare that with secant of 240 degrees. So now we know that on the left we have negative 2. Now let's find secant 240. So secant is the reciprocal of cosine. And if cosine is x over r, then secant theta is going to be r over x. 240 degrees is going to put me in this third quadrant. And same as before, I'm going to need to subtract 240 minus 180 to figure out what this reference angle here is. Notice that I'm always subtracting from 180, because that's the definition of the reference angles. How far are you from the x-axis? So it's either 180 or 360 if I was on the right side. So 240 minus 180 leaves me with 60 degrees. So I know that this reference angle is 60. Drop the perpendicular. That makes this angle 30. And now we'll label. Across from the 30, negative 1/2. Across from the 60, negative root 3 over 2. And my r is always 1. That was x, and this was y. So secant is r over x. That's going to be 1 over negative 1/2, which is, again, the reciprocal of the denominator, negative 2. So if cosecant and secant are both negative 2, then we can say they are equal. That's true. And to justify my answer, I would show my work. This would be my justification. Okay, let's move on to number 5. Which trig ratio would you use to find the measure of theta? So notice here's our theta. And we've got a triangle. Now, this is not a special right triangle because our side lengths are not 1 over 2, root 3 over 2, 1, or root 2 over 2. So we can't use our 30, 60, 90 information. Instead, we're going to use a different, we're going to have to set up a trig equation using the information that's given. So let me show you how I'm going to start. I'm just going to look at A first, okay? Let's see if this works. It says sine of theta. Well, if I needed sine of theta, it would be y over r. In this case, my y is 4. My r is 7.2. And my x is negative 6. So I want to see, is this equation set up correctly? Well, if I needed y over r, my y would be 4. My r would be 7.2. The equation I should set up is sine theta equals 4 over 7.2. However, you can see it's actually flipped here, meaning that this is not the proper equation. Another way you could have done the problem is using so, ka, toa, and using the fact that sine of theta is the opposite, which would be 4, over the hypotenuse, which would be 7.2. And either way, you're going to see that these are not the same. So we're going to cross it out, and we're going to just continue checking the rest of these the same way. Now, instead of using SOHCAHTOA, I'm just going to stick with y over r, x over r, and tan y over x. Just because, look, it's on an xy axis. So why not use x, y, and r? Let's check cosine. So cosine theta should be x over r. Well, my x is -6, so we're good. And then my r is 7.2, so we're good. That makes this a proper equation. I would circle it. It says select all that applies. There's more than one. Let's keep going. Tangent is y over x. So my y is 4, good. My x should be -6, but look, they only have a +6. So it's actually wrong, because the proper answer would have been 4 over -6, or basically -4 over 6. We're missing the negative, so that guy's out. Unfortunately, it's incorrect. Next, cosecant. So cosecant is the reciprocal of sine. Instead of y over r, then, we need r over y. Let's see if they got it correct. So r should be 7.2. 7.2 should be in the top, not the bottom. And then y should have been 4 in the bottom. Not only is it incorrect because of that reason, but there's an unnecessary negative here. This is out. Let's do secant now. Secant's the reciprocal of cosine, so instead of x over r, we need r over x. Let's see if they got it right. So r would be 7.2. That's so far so good. And then x is -6. So 6, and then there's the negative. They got all these pieces correct. The 7.2 in the top, the 6 in the bottom, and the negative in the front. So that's a good answer. Last one, cotangent. My cotangent formula, it's the reciprocal of tangent. So instead of y over x, I'm dealing with x over y. Let's see if they got it. X would be -6 and y would be 4. Looks good. They got the negative sign and the 6 over 4. So that would also be a good answer. Not so bad. Let's go to number 6. Now 6 wants me to match each trig function with its answer. So there ain't no way around it. We really have to do each one of these problems. It's almost like 4 problems in one. If you use your unit circle, it's going to be easier, but I'm going to do it the long way and show you each step. So sine of 5 pi over 3. First, we need to convert that to degrees. So pi over 3 is 60 degrees times 5 leaves me with 300 degrees. So I'm really looking for sine of 300 degrees. You could have found that conversion right on your unit circle too. Next, we're going to draw, or we're going to write our formula, which is y over r. And next, we're going to draw 300 degrees. So 300 is going to be in this quadrant. And if this is 300, I need to know this distance. How far is 300 from my x-axis, which is 360? So you can always do subtraction, the big number minus the smaller number. And you'll see that our reference angle is actually 60 degrees. Drop the perpendicular, and let's label our sides. So across the 60, -√3 over 2. Across the 30, +1/2. And then r is going to equal 1. This is x, and this is y. So sine is y over r. That's the same as -√3 over 2. All over 1. And as we know, anything over 1 is just itself, which is -√3 over 2. So I'm going to match sine of 5 pi over 3 with its equivalent answer. Next, let's do cotangent of 5 pi over 4. So convert it any way you like, but 5 pi over 4 is the same as cotangent of 225 degrees. 225 will be in this quadrant with a 45-degree reference angle, because it is, if this is 180, 225 is 180 and then another 45 degrees. Let's drop the perpendicular. Across my 45s, I get root 2 over 2, root 2 over 2. And these both happen to be negative because I'm going back on the x-axis and then down for my y-axis. And r is equal to 1. That's x, that's y. Cotangent's the reciprocal of tangent. So if tan theta is y over x, then cotangent's going to be x over y. So my x value is negative root 2 over 2. My y value is negative root 2 over 2. And when I divide something by itself, they cancel. The negative cancel with each other as well and turn into positives, and I'm left with positive 1. So I'm going to match cotangent of 5 pi over 4 with its partner, with its equivalent expression, which is positive 1. All right, next, secant of negative pi over 4. Let's do this off to the side here. So first, convert it to degrees. That's negative 45 degrees. Our formula, secant's the reciprocal of cosine. So if cosine's x over r, secant's r over x. And next we'll draw it. So regular 45 degrees takes me right here, but that's not what I want. I want to flip it over the x-axis. So negative 45, instead of going this way, will land me right here. Label your 45 degrees and drop the perpendicular. Here we go. This is root 2 over 2. This is negative root 2 over 2, x, y, and our r is equal to 1. So if my formula says to find r over x, that means I'm going to do 1 over, and my x is root 2 over 2. So when I have a fraction divided by a fraction, I want to make sure I'm able to multiply my numerator, which is 1, times the reciprocal of the denominator. So multiplying straight across, I'll get 2 over radical 2, and then I need to rationalize. My answer will be 2 root 2 over 2, and finally these 2's will cancel, leaving me with radical 2 as my answer. So I'm going to connect secant of negative pi over 4 with its partner, radical 2. We're almost done, guys. Cosine of pi over 3. So cosine, I'll do my work down here. Cosine of pi over 3. First of all, convert that to degrees, so that's 60 degrees. Next, write down your formula, that's x over r. And finally, you can use your unit circle or you can graph it like this. 60 degrees is right over here. Ooh, I'm going to draw this a little nicer. 60 degrees is right over here in my first quadrant. This is 30 degrees. And across the 60, you should see a root 3 over 2 on your unit circle. Across the 30, a 1/2. And our r is always 1. So my x, that's my horizontal side, is 1/2 divided by r, which is just 1. Anything divided by 1, you can just leave it as itself, 1/2. So cosine of pi over 3, I will match it with its bud, 1/2. All right, we're on to number 7. It says graph the measure and label the angle. So first let's graph this by converting to degrees. I don't know about you, but it's very hard for me to graph straight from radians. I need to convert to degrees first. So you can do this in any which way. You can look at your unit circle for the conversion. You can multiply by 180 over pi and simplify. The 3 goes into 180 60 times. And then you'll get 300 degrees. Or you can recognize that pi over 3 is really just 60 degrees, and I need 5 of those. So 5 times 60 will leave me with 300 degrees. So do it whichever way you got to do. But basically, you need to get 300 degrees as your answer. That's our first step. Next, we need to graph it and label the reference angle. So if I'm graphing this, 300 will be, if this is 270 and this is 360, it'll be between them in my fourth quadrant. Now if this whole piece is 300 degrees, I need the reference angle. That's the space between my angle and the nearest x-axis. So I need this angle. Well, if this is 300 degrees and this whole thing is 360 degrees, if I subtract them, I will be left with my reference angle right here. So to subtract them, I'm going to do 360, take away 300, and I realize that there's only 60 degrees between where I'm at and my nearest x-axis. That's called my reference angle. Oh, we're actually done. I don't know why I thought there was more work, but that's it. We graphed it. There it is in our fourth quadrant. And then we labeled the reference angle as 60 degrees. So let's call that theta r, which stands for angle that is the reference angle. And you're done. So just keep in mind that when you're subtracting to find your reference angle, you will only use these numbers. 360, that's if you're in quadrant 4. And you're going to use the number 180 to add or to subtract from when you're in quadrants 2 and in quadrants 3. If I'm in quadrant 2, you're going to do 180 take away to see what your reference angle is, because you're less than 180. But if you're in quadrant 3, that's down here, you're going to do 180 plus and see how much further you need to go, because you'll be greater than 180. So your reference angle, just so you know, is always 30 degrees, 60 degrees, or 45 degrees. Those are your options, basically, when we're dealing with special right triangles. All right, let's do number 8. Use the appropriate trig function to find the ratio. Draw the triangle in the appropriate quadrant. So this is telling me to find cosecant theta, and it's giving me some information about theta. It's saying that the cosine of the angle is 6 over 10, so immediately I should be marking that. That's x and that's r. Next, they're giving me some information about the quadrant. They're saying you're between 0 and 90 degrees. That means I'm in quadrant 1. So we'll start sketching based on the information we have. In quadrant 1, I'll draw my angle. My x is 6. My r is 10. And what I don't know is what my y is. So in order to figure out my y, by the way, this is theta right here. In order to figure out this length, I'm going to use the Pythagorean theorem, which is x squared plus y squared equals r squared. So I'm going to plug in what I know. X squared, that means 6 squared plus, I don't know what y is. And r is the hypotenuse, the longest side. It always goes on the other side of the equal sign. So it's going to be 10 squared. So next step, let's start solving for y. 36 plus y squared equals 100. I'll subtract 36 on either side. Y squared equals 64. And in the last step, I need to take the square root of both sides, so I get y equal to 8. So I figured out now the missing side is 8. Why is that useful? Well, look back to what they want to know. They want to know what cosecant of the angle is. So given now I know what my x, my y, and my r, I know all their values, I can just plug in. My cosecant formula is r over, it's the reciprocal of sine, and sine is y over r, so this is r over y. My r is 10, and my y is 8. So if let me write that a little neater. My r is 10 over 8. So if I divide top and bottom by 2, I get 5 over 4 as my final answer. So notice we didn't use any special right triangles here. We didn't even know the value of theta. It wasn't given like 30 degrees or 45 degrees. We didn't have any of that. Just based on the cosine information and then our Pythagorean theorem, we were able to solve for all of the values and then just use x, y, and r formula to figure out cosecant. All right, we're almost done here. We're on number 9 out of 10. It says, find the value of t given that, well, you can be between basically 0 and 360 degrees. So when you see a trig equation, this is called a trig equation because I'm using a trig ratio here, cosine, and there is an equation because of the equal sign in the middle. You should expect 2 answers when we're between 0 and 360. Here's why. Cosine can be positive. Notice this saying, what's the value of t? So what's the angle where cosine is positive root 3 over 2? Well, cosine can be positive in 2 spots. See if this comes back. All students take calculus. This tells me in which quadrants I have positive trig ratios. Well, in the first quadrant, all of them are positive, right? Sine, cosine, and tan, they're all positive. In the second quadrant, only sine is positive. In the third quadrant, only tangent is positive. That means that like sine is negative and cosine is negative because only tangent is positive here. And then in the fourth quadrant, only cosine is positive, meaning sine is negative and tangent is negative over here. So using that information, I need to figure out where is cosine positive. So I'm going to look at all students take calculus. Cosine is going to be positive in my first quadrant because all of them are positive there. And cosine will also be positive in my fourth quadrant because cosine's the only guy that's positive in quadrant 4. So given that information, I'm going to go ahead and draw 2 separate axes so that it's not getting too messy. So let's go ahead and start. Axis number 1, axis number 2. Okay, my formula for cosine is x over r. So here's what I know so far. I know x is equal to square root 3. I don't know what y is, but I'm going to put a plus or minus there. And then r is equal to 2. Again, this is how I know. R is 2 because it matches the denominator, and then x is radical 3. Now, we'll notice that r is equal to 2. That's unusual. R should always be equal to 1. So if we set r equal to 1, we're going to need to divide everything by 2. Divide everything by 2. So now we get r equal to 1, and x is equal to radical 3 over 2. So remember back to your big 3. Radical 3 over 2, that corresponds to 60 degrees. That means that when I draw my angles in quadrant 1 and in quadrant 4, the reference, that my x should be labeled root 3 over 2. I'll drop the perpendiculars. Okay, the x should be root 3 over 2. My r is 1. That means that my y has to be the 30 degrees. So that this is a 30, 60, 90 triangle. Well, if y is 30 degrees, that means it has a value of 1/2. So over here, it would be negative 1/2. Over here, it would be positive 1/2 because it's above the x-axis. Now that I've got all my sides labeled, I can figure out that my reference angle is 30 degrees. How did I know that? Well, because it's across the 1/2. And if that guy's 30 degrees, this guy's 30 degrees. So we're almost finished. We actually need to know what is the size of this angle. Well, 30 degrees, there's not much to it. We can just write t equals 30 degrees as our first answer. This one's a little trickier. because my answer is not 30. It's actually this angle. So if we know this is 360, then I need to stop basically 30 degrees before 360. You can do this math. 360 minus 30. That means that this angle right here, from there to there, is 330 degrees, and that's what I'm looking for. So, final step, we need to put these back into radians. So 30 degrees in radians is equivalent to pi over 6. And then 330 degrees in radians is equivalent to 11 pi over 6. You can use your unit circle, or you can do these conversions by doing pi divided by 180 and then canceling from there. Boom, boom, and so on. So those are our two answers for number 9. Last problem. Number 10. Below is Kim's work. Whoops.